and I'm Yiqi from the University of Hong Kong, and my supervisor is SMU. Today, we're going to present, and the title of my presentation is Deep Multiple Instance Learning for Forecasting Stock Trends using the financial news. Okay, to make it clear, we would like to go through our work according to the following outlines. First, I will briefly introduce the topic. Then we are going to talk about some related work. Next, we are moving to our proposed method. After that, we will show our experiments, give our results and result analysis in this part. And finally, we conclude and summarize our work in the last conclusion session. Okay, stock trend prediction has always been a hotspot for both investors and researchers to make easy making useful investment decisions or gain profits. And normal trend prediction tasks mainly take direct views on the stock prices. And based on stock prices, fundamental analysis, technical analysis, and historical price time series analysis has been used to help in previous stock prediction tasks. And besides stock price, a major source of information can also be taken from financial news articles or the events reported in financial news. Intuitively, people intend to buy stocks on hearing positive news and also sell on hearing negative news. And using financial news to predict stock trends can be regarded as one text binary classification task. A given certain news corpus in a certain of training days. And we classify or predict a trend as uptrend or downtrend. And there also presents some challenges that hinder the news-based trend prediction. And we analyze these challenges and show how our work is motivated and deal with these challenges. And for challenges in news-based trend prediction, one is the uncertainty in financial news. And it comes from two sources, uncertainty in occurrences of news each day, and also the uncertainty in the distribution or the number of positive and negative news each day. For the uncertainty in occurrences of daily news, as it can be seen in Figure 1, financial news appears randomly and most of the time. And sometimes there's no relevant news in one day, while sometimes there can be more than 60 or to 80 news in one day. In views of uncertainty in the distribution or number of positive and negative news each day, the stock trend is generally related to a certain amount of financial news instead of one pieces. And on a day with stock trends going down, I think it's quite unrealistic to consider that all the news within this day is negative. Besides negative news, there are also some positive or neutral news as well. In real life, there also exist difficulties in getting individual news labels. Considering the random and rapid changes in news amounts, and the labeling of individual news is quite expensive and impractical. And also, investors also have some risk preferences to treat or mark each piece of news. And we don't have uniform standards. This also increases the difficulties of labeling individual news. The news labels are unknown sometimes, but we also should not ignore it. And because Sudden good news could alter investors of his previous bearish decisions when doing trading. And what's more, if an investor only look at single news, they will make an opposed decision. And for example, for news on September 20, 2011, and the final trend of the day is downward. If one investor only looks at the first two news, which conveys positive signals, say a boost or increase, and they will think that the stock may go up instead of downtrend. Therefore, we should not ignore the news labels in precise stock prediction. Actually, as one type of weakly supervised learning algorithm, the multiple instance learning, MIL, can be utilized to infer unknown news labels and also the Greek correlation between them. It helps deal with the challenges on the uncertainty of financial news mentioned above, and it can also construct models at the instance and back levels. Therefore, in this work, we consider the effects of financial news on stock trends from the perspective of multiple instance learning. So our work is going to include news labels information or the probability into our MIL model when we're predicting the stock trends, and also give empirical evidence to prove that our proposed model can achieve impressive results competing with other neural actual architectures and previous MIL methods. So we review some related work. And in multiple instance learning, the training set comprise labeled bags. Each bag is a collection of instances, and the label is only known for the entire bag. But the label of each instance inside the bag is unknown. The appearance of multiple instance learning is gained interest by researchers because it alleviates the burden of obtaining limited labeled data sets. And it has also successfully put into practice in areas like image classification, document modeling, event extraction, sound event detection, etc. In the original assumption of multiple instance binary classification, a bag may be labeled negative if all the instances in it are negative, and a bag is labeled positive if there's at least one instance is positive. So for object detection, an image is separated into many segments to detect a bear. If there is at least one segment detecting the bear, then the image is labeled as positive or bear detected. Otherwise, the image is labeled as negative or no bear detected when there's no segment that detects the bear. That's the original assumption of multiple instance binary classification. However, this original assumption is not suitable for financial news analysis. As previously mentioned, first, it's quite unrealistic to think all the news within a downtrend day are negative. And second, if there exists at least one positive news, then all prediction will be positive, and this will cause severe label imbalance issue. So our work is going to extend original assumption, and we directly infer the probability that one financial news belonging to a certain label, and we find the weak correlation between news. And we also review some existing work pertaining to financial news for stock trend prediction. Financial news contains useful information in unstructured textual form, and we presenting each news title can be important to extra semantic and context information within news title. So for news vector representation in recent studies, there are classic methods like averaging word vectors, training paragraph vectors, and gain structured event representations. And later, by directional STM with attention mechanism and distributed representation of news has also adopted in state-of-art prediction. As predictive methods, deep learning like convolution neural network, recurrent neural network by GRU, or recurrent convolutional neural network, RCNN, etc. And these methods also present high performances in traditional natural language processing tasks and have grown as mainstream and state-of-art techniques. And here comes our methodology. And in this section, we describe the framework of our proposed multiple instance learning model. We first define our problem in the scenario of classifying stock trends using news. We consider the prediction of the stock over M trading days, and given an input data set D, we regard news as instance and all of the news that appears in one day as a bag. So in each trading day or in each bag BK, there contains NK piece of news, where K is in the range of 1 to M. And as for the bag labels YK, the bag labels are obtained through the change of two consecutive stock closing prices. If the closing price of one trading day is higher than its previous day, and the stock trend would be up, and we label it as 1. Otherwise, it will have a downward trend. We record it as 0. Then we have the data set D equals the news corpus BK as well as its label YK. And we have the proposed model has 4 stages. First is word embedding, and second is the news encoding, and later comes with the news level classifiers. And finally, we conduct the back level representation and also classification. And on a trading day BK with NK news titles. And for news title NI, it contains TI words. And we record each word WITK, which stands for the T's words in news NI of day K. And we first embed the individual words WITK to vectors through word embedding matrix LW. Then the embedding vectors EITK is scanned through the following equation that EITK equals LW multiply WITK. As for the pre-trained word embeddings, we use globe here for better representation of words. For news encoding, we first employed bidirectional long short-time memory after word embedding to incorporate the contextual information of words. And the recurrent structure in LSTM promotes the capture of context information, and its gated mechanism also make it more applicable in modeling semantic of long text. The bidirectional LSTM also contains the past and future context of the word. And since words within the news are not equally informative to investors, and usually investors pay more attention to keywords when they see a news. In this case, we introduce a word attention mechanism on top of the by LSTM. The word attention rewards the words that offer critical information. And finally, we obtain the dense representation of NIK for each piece of news in bag or day K. On news representation, after we obtain the news representations NIK, we construct news level classifiers to make news level predictions. And for the classifiers of news, we feed the news vector NIK into a one layer MILP with sigmoid activation. Then, and we get the predicted probability that one piece of news belongs to a particular label, P, that the prediction probability is PIK. Say, and through the PIK, our news labels can be inferred. Compared with original MIL assumption, we directly infer the probability of each instance belongs to a particular label. And after we infer news probability through news level classifiers, we multiply the news probability PIK and the news representation NIK, and we would and then we will get the day or vector representation ZK, and based on ZK, we built the day level classifiers and get the predicted day level probabilities through day level classifiers. Through encoding miner, our MIL framework from instance to bags can be parameterized through the neural networks and also be able to train end-to-end. And in this case, by comparing the predicted day level probabilities against the actual day labels, we can compute a cost function, and then the network is trained to minimize the cost. And that's the whole framework of our methodology. So to conduct our experiments, the data set we use is a set of financial news between October 2006 to November 2013. And this data set contains around 100,000 news from Reuters and also around 400,000 news from Bloomberg. To catch the time period of the financial news, we also collect the historical stock price data of S&P 500 index at the same time from Yahoo Finance. Then we conduct a series of basic text pre-processing on news. Pre-processing steps include lowercasing and tokenizing each news, removing the stop words. After that, we filter out unrelated news. Unrelated news means contains no stock symbols or any company names. And for our final step in processing, we split the data set and gain the training, validation, and test set. As for the setting of our experiment, we use adult delta as our optimization algorithm, and we set the initial learning rate as 0.1, mini batches as 32. We adopt globe as the pre-trained word embeddings, and the embedded dimension is 100. LSTM hidden units are 50, and the attention vector dimensionality is 100. And LSTM for hidden layers within the news classifiers, we set it to 150. Also, to prevent overfitting, we adopt a dropout rate of 0.5. To evaluate our model, we compare our proposed methods with some mainstream models and previous MIL models. We take the classification accuracy as our evaluation and obtain the experiment results. And as it can be seen in following table and figure, our proposed framework, MIL-REP, can achieve a predominant accuracy of 63.060%, outperforming the baseline models. Although event embedding is in EBNN is competitive, our proposed multiple instance learning framework is still powerful in the extraction of financial news for trend forecasting. We also make result analysis on some aspects. For the expression of news, we use a simple average embedding, which is presented as S, and encoding weights by LSTM attention mechanism, which is presented as ATT. We see results of MIL models as GICF versus ATT GICF, MILS versus MIL-REP, and also see results of non-MIL models, namely LSTM versus ATT LSTM. And the results for both MIL and non-MIL model showed that better performances can be derived from the news representation of by LSTM and attention encoding, compared with the simple average embedding. Our proposed multiple instance framework is also compared with another previous MIL framework with group instance cost function. And table 5 shows the properties of two kinds of multiple instance framework. And the difference between ours and MIL, previous MIL with GICF function is whether to process instance vectors in back prediction, and also the minor to include inferred instance labels in back prediction. In previous MIL with GICF function, back label is obtained by aggregating instance labels, such as averaging, maximum, or optimization. And then the instance factors are no longer get further processed anymore. And in our methods, and we encode the possibility of instance and still process instance vectors into the back representations and build the back level classifiers to get the back labels. By comparing SGICF versus MILS and ATT-GICF versus MIL-REP, in table 6, we can see that results in model GICF-based model are modest and with less than 60% accuracy. And the reason behind it that MIL with GICF function is instance label oriented and not include further vector operation at back levels. And the generation of capability of averaging aggregation is relatively poor. And for MILS and our proposed MIL-REP, the inferred instance probability is encoded into the back vectors. And the fitting effects are greatly enhanced by this embedding minor. And the learning and generation capability also improved better than SGICF and ATT-GICF models, and also other non-MIL baselines. So to conclude, In our paper, we analyzed news-oriented stock trend forecasting from the perspective of multiple instance learning for the first time. We point out the challenges in this task, the uncertainty of financial news, and also the difficulties of getting news labels. To deal with these challenges, we developed an adapted end-to-end MIL framework. And experimental results on SP 500 index demonstrate that our proposed model effectively increased performances. And here are some inference mentioned in our slides. And that's it, the end of my presentation. And if there's any question, feel free to ask me.